So earlier today, I finished. Well, I made Conway's Game of Life in Mojo, just terminal version, not like anything like with no GUI or anything like Pygame. Um, but I followed Mojo's official tutorial. The Get Started with Mojo page literally tells you how to make the game in Mojo, which is pretty cool. And I was gonna go ahead and add like a GUI to it. I mean, like by GUI I mean like actually like render pixels, so it looks like this basically, right? Um, I was gonna do that, but I figured it'd make more sense to actually read the docs first and kind of, well, yeah, read through the language first, and only then continue it. Because then like I have more like a bigger idea of the language's features, and then I can use those to my advantage. So yeah, let's go. So Mojo is designed with Python programmers in mind, but it isn't just Python only faster. Mojo introduces a type system, unsupervised semantics, and low-level control that, as a Python developer, you may not have had to reason about to make your code work. And that's interesting. I did not. Yeah, I mean it's designed with Python programmers in mind, but I guess it's not made for Python programmers. If anything, I wonder if it tries to attract any C++ or Rust developers. I wonder if it cares to do that. Because right now it seems to be mostly trying to grab at Python developers, which is good, you know. Get the Python developers into real programming, you know, into the low-level stuff. It's good. It's good. Mojo looks like Python, but its execution model is closer to Rust, Swift, C++, and other systems languages. Yeah, Swift is also a systems language actually. That was another one that I was considering, but it uses reference counting, which isn't bad, but it's like it's one step down from a garbage collector, but still one step up from from just raw low-level access. So Swift isn't bad, but not what I'm looking for. Also, Swift is predominantly made for Apple devices, and I don't have Apple devices, nor do I want to make apps for like Linux, Windows, and Mac OS. I mean, cross-platform ideally, but I know you don't have to use Swift for Mac OS or iOS, but it's a lot better suited for it. So probably not gonna hop on Swift anytime soon anyway. But yeah, Mojo. Mojo is statically typed, compiles to machine code. Yeah, I don't know. To be fair, I don't actually care that much about this page. It's more just tips for Python developers. So let's skip ahead here. System requirements. For Windows, you need to use WSL, which is a bit funky. I don't even know what WSL is. Is it like a virtual machine? Women's Super League. No, Windows Subsystem for Linux. Right, so you have to run it through Linux basically, which is kind of hilarious. But would definitely hurt adoption, right? Surely. But I guess most people who do like AI stuff anyway would be either using Linux or SSHing into Linux servers, because that's where the AI stuff would be stored, I assume. Then again, like, NVIDIA hasn't been that nice with Linux, even though Linux, yeah, I don't know. Because I mean, I know that Microsoft and NVIDIA are in cahoots, so I wonder, yeah, I wonder if Mojo is backed by any particular company. I'd be surprised if it's NVIDIA, just because it's not on Microsoft. Unless NVIDIA and Microsoft had a fallout that I'm not aware of. Yeah. How do I even check? Is there like licenses, privacy settings, releases? Is there like a thing I can check? Like, how is this thing even made in the first place, you know? There's the modular company, right? So let me check modular. These are the top contributors. Quite a few of them actually. Modular. Inference from kernel to cloud. Right, this is the main website. Unified Stack. Microsoft, Intel, MediaMax, InWorld, NVIDIA, I know they did a new like collaboration with Minimax, whatever that means. I don't know Minimax before this. Herevia, Moneylion, Jabberly, Yext. Okay, whatever. AMD, and Nvidia, Amazon, and ARM. Okay. Yeah. It's like I don't know like if they're backed by anyone. What even is this company? They have AI models. No, they don't. These are existing models. So Minimax is one, DeepSeek obviously, Kimi. I mean these are open source, right? Your custom model. TPU for Google, Trainium, Apple Silicon. I don't know. Like what is modular? Get started. Sign up. Okay, whatever. You need a C compiler on Linux for linking. Okay. GPU's optional. Yeah, I don't use GPU programming, so it's fine. Supports it across NVIDIA, AMD, Apple Silicon. I believe mine's Intel. Integrated graphics card, so I don't think that matters. NVIDIA, AMD, Apple. Okay. I don't know. Overview. What is this language for ultimately? Like, can I use it just as a systems level programming language in general, or is it specifically meant to be for AI? I assume it's not for AI only, considering the example it gives you is for Conway's Game of Life. Now I'm aware that could just be to teach you the ropes anyway, but like, it would be nice if this was more general purpose anyway. If you know Python, then a lot of Mojo code looks familiar. However, Mojo incorporates features like static type checking, memory safety, next generation compiled technologies, and more. As such, Mojo also has a lot in common with languages like C++ and Rust. In common. If you prefer to learn by doing, follow the Get Started with Mojo tutorial. I did that. On this page, we'll introduce the essential Mojo syntax, so you can start coding quickly and understand other Mojo code you encounter. Subsequent sections in the Mojo manual dive deeper into these topics, and this page links to them as appropriate. So Mojo is a young language that is still evolving. Got a link there. As such, Mojo is currently not meant for beginners. Okay. Even this basic section assumes some programming experience. The Get Started with Mojo was pretty good actually, for people who don't have experience. However, throughout the Mojo manual, we try not to assume experience with any particular language. Good, because I've read quite a few language specs to this point, and some of them like both assume and do not assume you know certain languages. Like when we like sometimes I'll be reading a documentation, like it'll just say something that I'm like expected to know, even though I don't necessarily know that thing. But then in like another instance, it will like tell me what a variable is, even though every language has that. So very weird. Anyway, this goes over like the basics it seems. Unless these are underneath. Yeah, like ownership and all that stuff is under different sections. But yeah, I mean, I'll still go through the basics, because there tend to be some subtleties there. Traditional hello world, define main, hello world. Every Mojo program must include a function named main as the entry point. Okay. We'll talk more about functions soon. The print function does what you expect, printing its arguments inside an output. I guess if you know what print is. The page omits def main from many brief examples. To test these, add them to a main function. Variables. In Mojo, you can declare a variable using the var keyword. You can also explicitly declare the variable type with or without an assignment. Mojo variables are statically typed. That is, Mojo sets a variable type at compile time, and the type doesn't change at runtime. If you don't specify a type, Mojo uses a type of the first value assigned to the variable. So inference. For more details, see the page about variables, blocks, and statements. Interesting how functions, the functions page is before the variables page actually. Define code blocks such as functions, conditionals, and loops with a colon, followed by intermittent lines. All code statements end with a new line. The Mojo compiler is fairly lenient in allowing extra line breaks. Okay. Generally speaking, use parentheses to continue statements across lines. Fair enough. Mojo combines adjacent string literals. Yeah, I'm a bit iffy on that one. Define Mojo functions with the def keyword. For example, the following uses the def keyword to define a function in Greek that requires a single string argument. Code comments. I mean, this is the overview, right? Hashtag. Triple quotes for comments. API comments. That's weird. I don't like that because it, like that looks like a multi-line string, but they're doc strings. They aren't comments. They're essentially using Mojo syntax for multi-line string literals. Okay, now. Okay, so they are multi-line string literals, but they're also used for comments in this regard. I wonder how that's gonna work. Like, can you like generate documentation dynamically? Is that what it's saying? Structs, you can build high-level abstractions for types or objects as a struct. A structure in Mojo is similar to a class in Python. They both support methods, field operative loading, decorators for programming, and so on. However, Mojo structs are completely static. The compiler binds them at compile time, so they don't allow dynamic dispatch or any runtime changes to the structure. Yeah, runtime changes to structure are quite interesting. Dynamic dispatch. So no inheritance, basically. There are traits though, but I guess traits don't use dynamic dispatch. What's this star? I wonder. Oh, stars for. I think it's for named arguments, enforcing named arguments. I could be wrong, but that's what I remember. For example, these are basic structs. Yeah, init. You can overload. Okay, good to know. And here's how you can use it. Not a fan of these kind of constructors anyway. I prefer if they're more explicit in their return, so you can return errors as well. But I don't know. I'll see if I even want to use. Well, exceptions or errors by values. I don't even know if it has an effect system, or if it just has the raises thing. An effect system would be nice, but I don't think it does. The myPair struct contains two special methods: init, the constructor, and init. Oh, that's the copy constructor. Okay. So that's how you can overload that. Oh, in that case, can I overload the constructor, or can I only overload these individually once? Lifecycle methods like this control how Mojo creates, copies, moves, and destroys a struct. So the normal constructor must be the move constructor. Oh no, I'm wrong. Actually, that's not correct. For most simple types, you don't need to write the lifecycle methods. You can use the fieldwise init decorator to generate the boilerplate fieldwise initializer for you. And Mojo synthesizes copy and move constructors if you want them with trait conformance. Yeah. Now, I said it in the last video as well, but although... Okay, first of all, let me move myself. Although this does have the issue of being a language built on Python syntax, and therefore a lot of the syntactic smells of Python carry on to Mojo. Like this fieldwise init thing, for instance, I'm not a fan of that. Despite that, it's still better than C, you know? Like, the baggage that C++ suffers from C is not as bad as I think Python would give this language. Traits. A trait is like a template characteristics for a struct. If you want to create a struct with the characteristics defined in a trait, you must implement each characteristic. Yeah. Each characteristic is a requirement for the struct. And when your struct implements them, it conforms. Okay, language. Using traits allows you to write parameterized functions that can accept any type that conforms to a trait, rather than accepting only specific types. For example, here's how you can create a trait. I didn't see the generics, actually. I assume it has generics, one way or another, but we didn't see it so far. The three dots following the method signature are Mojo syntax, indicating that the method has no implementation. Okay, so that is actually built in. That's handy. I'd rather use it for like variadic arguments. I wonder if it supports variadic arguments. It must do. I mean, print does, but print is special, so I don't know if it does. I hope it does. Yeah. The three dot. Yeah, okay. Here's a struct that conforms to some trait. Sure. Here's a function that uses the trait as an argument type. Oh, look at that. Templates or generics. Yeah, function with traits. I wonder if Python has this or if this is a Mojo thing, like exclusively. T, some traits. I guess Python doesn't have traits, so it wouldn't make sense. Or does it? X is of type T. You'll see traits using a lot of APIs provided by Mojo's standard library. For example, Mojo's collection types like list and dict can store any type that conforms to the movable trait. And dict must also be key elements. Okay. You're probably wondering what the square brackets on function with traits. These aren't function arguments. These are compile time parameters. See, for my language, I know, like, take Zig for instance. Zig mixes them together. For my language, I was wondering if I would also have them keep them separate, like C++ and Rust do, and now Mojo, because then like it's easier to separate compile time parameters from runtime parameters, unless I want to treat them the same. I don't know. I'm still thinking about that. Without traits, the X argument in function with traits would have to declare a specific type that implements a required method, such as some structs. But the function would accept only that type. With traits, the function can accept any type for XX. Yeah. It is a parameterized function because it accepts a generalized type instead of a specific type. And speaking of the devil, parameterization. In Mojo, a parameter is a compile time variable that becomes a runtime constant, and you declare it in square brackets on a function or a struct. Yeah. So for my struct, for instance, for my in the Conway's Game of Life, I had a grid struct, but I had the row count and column count be runtime arguments. What I could do is make them compile time. So I might do that later. Many other languages use parameter and argument interchangeably. Yeah, I don't like that because they're not the same. So be aware. I mean, what languages even? Yeah, like what languages do that? Because they're not the same thing. It's more of a habit of programmers. So be aware that when we say things like parameter and parameterized function, we're talking about these compile time parameters. In contrast, a function argument is a runtime value you declare in parentheses. Right. Yeah, I mean, in C++, the parameter is the structure, and the argument are the values that you pass. So that's just another distinction now. Kind of annoying, but okay. Parameter. Parameterization is a complex topic that the metaprogramming section covers in much more detail. Okay, so it's not a metaprogramming. But we want to break the ice just a little bit here to get you started. Take a look at this. Take a look at a parameterized function. So repeat takes count of type int. Yep. So that has to be compile time. By specifying count as a parameter, the Mojo compiler can optimize the function because its value can't change at runtime. And the comp time keyword in the code tells the compiler to evaluate the for loop at compile time, not runtime. It also means that you can't pass it dynamically, right? The compiler effectively generates a unique version of the repeat function that repeats the message only 3 times. This makes the code more performant because there's less to compute at runtime. Similarly, you can define a struct with parameters, which effectively allows you to define variants of the type of compile time, depending on their parameter values. Python integration. Mojo supports the ability to import Python modules as is. Okay, it doesn't mention the fact that if you do that, then you can't compile. Hopefully this page has given you enough information to start experimenting with Mojo. Okay. Functions. Mojo uses a def function keyword to define functions. Functions are classified as structural methods. The fn keyword is deprecated. Use def for all function declarations. It's tragic. We'll find these. I understand though, because it's Python. Parameters, arguments, return value, optionally, and a function body. Pass, I guess, is like dot then. Okay. Yeah. Rank int, my tensor rank, sure. It's kind of skipping through these a bit, because I mean, it is a lot of redundancy with what I've seen before. So none is the void. So like, yeah, I mean, like how Rust and C++ have void, none is this language is void, which is a bit weird actually. I wish it was like nothing or something like that, or like unit, but I mean that'd be a bit too functional. Does this language have first class functions even? Like lambdas? It does. Closures and lambda expressions. I wonder how those look. I mean, like they're not that important in language, to be honest. I mean, it's a bit of a crazy thing to say there, but like generally speaking, I find that I don't even use them that often. Python lambdas. Lambda A. Oh god, please don't not use the lambda keyword because that's painful, man. Named result in the argument list. Oh. Right, so out parameter is that. Okay. Why does the constructor use an out parameter? I just realized the constructor for structs use an out parameter, an out self, as opposed to just returning self. Again, not a fan of that. Function arguments with slash and times in the argument list. Yeah. Arguments before the slash can be passed only by position. Arguments after the star can be passed only by keyword. For details, see position only in keyword. I mean, this is great. Like, this is like one of the main features I want from C++ and Rust. Neither languages are adding it, so hey, Mojo does it. I'll use it. I love it because I need it, man. You also see argument names prefixed with 1 or 2 stars. An argument name prefixed by a single star character, like star names, identifies a variadic argument. Let's go. While an argument name prefixed with a double star is a variadic keyword only argument. Cool. Honestly, awesome. I mean, like, love or hate the syntax is a bit goofy and like very arbitrary, but it's good that it supports it. Optional arguments. An optional argument is one that includes a default value, such as the XP argument here. Times is power, right? Yeah. However, you can't define a default value for an argument that's declared with the mutable argument convention. Yeah, makes sense. Any optional arguments must appear after. I mean, this is great. Like, why can't Rust just support this? We don't want overloading. We don't want different arguments. We can't have main parameters. Just do it, dude. Like, we can't have variadic things. We need macros for that. I don't like Rust. I don't like Rust. You can also use keyword arguments when calling a function. Keyword arguments are specified using the format argument name equals argument value. When calling a function. Yeah. Okay. Variadic arguments. Sorry, why? Why is this just like here as like a side note? It's a bit weird. The variadic argument values here is a placeholder name that accepts any number of past positional arguments, and you operate it on it like a list. It's pretty cool. You can define 0 or more arguments before the variadic arguments when calling the function, and your remaining positional arguments are assigned. I mean, the fact that they look like lists kind of says something about how those features could be united. Homogeneous variadic arguments and heterogeneous, where they're different argument types. The function section describes how to work with homogeneous and heterogeneous variadic arguments. When defining a homogeneous variadic argument, all arguments must be the same type. Use star argument type. Okay. That's okay, so it's called variadic list. Iterating over this list directly with a for in loop currently produces a reference to the element, which can be mutable with a mute variadic list. Cool. Using the ref binding pattern to capture mutable reference, I'm going to mutate the elements of the list. Oh, so you have to do ref I. Okay, well, the more you know. You can also directly index the list with integers as well. Yeah. Heterogeneous variadic arguments. Implementing heterogeneous variadic arguments, each argument type will be different, is somewhat more complicated than homogeneous variadic arguments. To handle multiple argument types, the function must be parameterized. Okay, which requires using traits and parameters. Okay. Archetypes in table or intable. I don't know. What's intable trait? Yeah, it makes sense. I mean, it's pretty much what I'd expect. So arg becomes a variadic pack because the syntax creates a heterogeneous variadic argument. That means each element in arg can be a different type that requires a different amount of memory. To iterate through the pack, the compiler must know each element's type, so you must use a comp time for loop. Cool. Like a const expert for loop, right? Notice that when calling count many things, okay, variadic keyword arguments. Mojo functions can also support varied keyword arguments, kwargs. I've seen that before. That's weird. Varied keyword arguments, like I've seen kwargs before, allow the user to pass an arbitrary number of keyword arguments. To define a function that takes care of varied keyword arguments, use varied keyword argument syntax. What? What? I don't know. Okay. Is the var necessary? Is it? Maybe. In this example, the argument is named kwargs as a placeholder that accepts any number of keyword arguments. A, Y. Oh, it gives you the key and the value. Right, yeah, no, I didn't see that. That's handy. I mean, that's basically what a map takes, right? That's cool, actually. Having it as like a first class feature is pretty cool. These are currently a few limitations. Varied keyword arguments once you declare with the var. It may mutate it. Okay. What's in? All varied keyword arguments must have the same type, and this determines the type of the argument dictionary. For example, if the argument is var, then the argument dictionary will be stringed float. Yeah, so you can't have different types. But I mean, like, those are like edge case. I mean, like, honestly, obviously it'd be nice if it supported it robustly, but at that point, it's probably quite a niche thing. The argument type must conform to the calculable type. Dictionary unpacking is not supported yet. Okay. Varied keyword parameters are not supported yet. Sure. I mean, I wouldn't ever use, like, I would almost never use varied things with keywords anyway. Positional only and keyword only arguments. When defining a function, you can restrict some arguments so they can pass only as positional arguments. Blah, 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 blah. The min function can be called with min 1, 2, but can't be called like a equals 1, b equals 2. Yeah, this. You want the freedom to change your argument names later on without breaking backward compatibility. Pretty cool. For example, in the min function, the argument names, can you have aliases like you can in Swift? I don't really care about those, but it can be quite handy. For information on positional arguments, see PEP 570. What? What's PEP? Like a proposal? Yeah. But these were implemented, right? That's crazy. I've seen these for C++, but never for another language, which is kind of funky. Keyword only arguments are the inverse of position only arguments. They can be specified only by keyword. Yeah. Do like the workarounds I've seen Rust programmers do to insist that they don't need this feature is ridiculous. It's actually ridiculous. If the function doesn't accept varied arguments, you can add a single star to the argument list to separate the keyword only arguments. Keyword only arguments often have default values, but this is not required. Well, why? What? Do they? If a keyword only argument doesn't have a default value, it is a required keyword only argument. It must be specified, and it must be specified by keyword. Obviously, I don't. Any required keyword only arguments must appear in the signature before any optional keyword only arguments to these words. That is, arguments to appear in the following sequence in the function signature. So required positional, then optional positional, then variadic, then required keyword only, then optional keyword only, and so on. I mean, that's fine. Overloaded functions. You can overload. All function declarations must specify argument types. So if you want a function to work with different data types, you need to implement separate versions of the function that each specify different argument types. This is called overloading a function. That's pretty funny. If you pass anything other than into a string to the add function, you get a compile error. That is, unless enter a string can implicitly cast a type into their own type. A string includes an overloaded version of its constructor that supports implicit conversion from a string literal. String literal is a different thing. Thus, you can also pass a string literal to a function that accepts a string. I guess it would be, but okay. When resolving an can I assign that and store that? When resolving an overloaded function call, it must be able to, right? If it's low level, the Mojo compiler picks the candidate that best fits the call according to the rules in overload resolution. An overload set is a collection of function overloads that share the same name but different signatures. They cannot be extended by imports, LECs are parameters. Yeah. To avoid issues with local functions using the same name as an imported one, use an alias import. Okay, overload resolution. Ignores the return type. Ignores the raises effect. It says the raises effect, which implies that there are other effects. But I'm not seeing any effects thing here yet. Foo hello is ambiguous and creates a compile error. Yeah. Yeah, for the full overload resolution rules and edge cases, see the function declarations reference. Return values. Return value types are declared in the signature using the type syntax. Right, yeah. Show me named results, I'm kind of curious. Named function results allow a function to return a value that can't be moved or copied. That can't be moved or copied? When is a value not able to be moved or copied? Or return by reference even, like. The out argument convention identifies an initialized variable that the function must initialize. The out argument for a named result can appear anywhere in the argument list, but by convention it should be the last one. Well, then make it the last one. A function can declare only one return value, whether it's declared using an out argument or using the standard type syntax. It's annoying. A function with a named result argument doesn't need to be. I mean, I think it's annoying. I would like something a bit more powerful. A function with a named result argument doesn't need to include an explicit return statement, as shown above. Yeah. I mean, what was it returning? If the function terminates without a return or return statement with a value, the result of the out argument is returned to the caller. I mean, why? Yeah, just why? Why even out and not just have return? Like, why is it out and on like on the just have it on the other side of the arrow? I don't understand that. But okay. Because the return value is assigned to this special out variable, it doesn't need to be moved or copied when it's returned to the caller. This means that you can create a function that returns a type that can't be moved or copied. I still don't understand that. By contrast, the following function with a standard return value doesn't work. When is a thing not copyable? How is it not copyable or movable? If you can't move it, and you can't copy it, then like what is it? Is it like some like semantics thing? I don't understand. Because create immovable object 2 uses a local variable to store the object while it's under construction, the return call requires it to be either moved or copied to the callee. I still don't get that. Raising. Mojo functions are non-original by default. And there are typed errors. So typed errors are just for custom error types. Yeah, like Java. Okay. Variables. A variable is a name that holds a value or object. Logical storage location. So var declares a logical storage location, binds the name greeting to that location, initializes a storage space with a newly created string value, owned by the value. Use var with a name, give it a value, whatever. The way you annotate, the easier it is to read and maintain. A variable type never changes, at least for now. A variable to scope to the block emission is declared. Block level scope. Lexical scoping. Okay. The var statement inside the if creates a new variable with the same name as the other variable. There is shadowing. Not a fan of shadowing. It can be quite confusing. Copying and moving values. Source is a copy by default. I mean, for some reason strings are copied by default. I don't get that. Like, why not have move by default? Like Rust does. The first assignment is no problem. Okay, each icon depends on type features. A credible type can be copied explicitly. Yeah. It's transfer. I don't know why they call it a transfer and like not just a move. But I guess it's like you're transferring ownership, so it is a better word. Reference bindings. Some APIs return references. References avoid copying values. Yeah. If you assign a reference to a variable, it creates a copy if the value is implicitly copyable. Or an error. Okay. To name a reference, use the ref keyword to create a reference binding. So there's no const. It's all var. So even non-variable variables are var. It's interesting. Not my favorite. I do also like the Rust one the best, where you have let and let mutable. That's just, yeah, it's just good. And then have comtime and comtime mutable. That's also fine. All values in Mojo have an associated data type. Most of the types are nominal. I mean, Rust doesn't have comtime mutable, but I do like mute being a modifier rather than having two different keywords for variables and constants. Most of the types are nominal types defined by structs. These types are nominal or named because type equality is determined by the type's name, not its structure. Yeah, I do wonder about that. There are some types that aren't defined as structs. Functions are typed based on their signatures. Non-type is a type with one instance, the non-object. So it's like unit. Mojo comes with a standard library that provides a number of useful types and utility functions. These standard types aren't privileged. Each of the standard library types is defined just like user-defined types. Even basic types like int and string. But they are the building blocks, yeah. Built-in types are always available and don't need to be imported. The standard library also includes many more types that you can import as needed, like collection types, blah blah blah. I think lists are also built in. Numeric types, signed, unsigned, floating point. They do support both numeric and bitwise operators. Oh no. Integers and unsigned integers. There's int 8, int 16, int 32, int 64, so on and so forth. Int is just whatever width the system uses for its word size, I think. These general and fixed position integer types are aliases to the simd type. Okay, interesting. SIMD type, really. Have a look at that. Wait, that's a link to the standard library docs. Definitely have a look at this. dtype.flip32. What's dtype? Int represents a signed integer that uses the system's native word size. You may wonder when to use int and when to use other integer types. In general, int is a good safe default when you need an integer type and you don't require a specific bit width. Using int as a default integer type for APIs makes APIs more consistent and predictable. Yeah. Signed and unsigned integers with the same bit width can represent the same number of distinct values, but over different ranges. Overflow behavior. When a signed integer overflows, the value wraps around. Oh. So there's this implicit wrapping, which honestly isn't like it's something a bad thing, because like it's pretty obvious when something wraps. But you would prefer if you can prevent it from happening in the first place. I mean, Rust does the same thing. It wraps in release builds, and it panics in debug builds. It's just Rust is weird, dude. I mean, not weird. It's annoying. You would prefer unsigned integers when negative values are not required. Damn, it goes to int256. Can I even use int256 on a platform that doesn't like officially support it? That's cool. Why would you? I mean, I get needing like a 256-bit register for like SIMD operations, but why would you need a uint256 as like a value? That's kind of wild. I mean, that's literally like the number is massive. Surah al-Baqarah, yeah. No. Like, how big is that number? I mean, even like 64 is really huge. 64 goes to 19, which I believe is like, I mean, it's 19 zeros. So divide by 3, 6, roughly. So you go thousands, millions, billions, trillions, I think quadrillions. I think that's what that reaches. 128, 38, 256, I mean... Anyway, floating point numbers goes to 64. Tragedy. I mean, it's IEEE, whatever. Float literal. Huh. That's interesting. Very messy, but it's interesting. Wait, infin. Inf is also a thing though. And neginf. Are these like actual like stand-ins for these values? Oh no, it's fine as variable. Why not just build that into the language, I wonder? To be fair, like how often do you work with infinity? Floating point approximations, rounding errors, space. There's a math.isClose function. Alright. The EXMX format. What? The number of bits allocated to a floating point numbers exponent and mantissa. Huh. And that's built into the name. Also messy, but yeah, it's something. Don't know why FN is at the end there, but okay. What's FN? I don't understand. It's called B floats. Oh, it didn't list it yet. This is the definitive list. FN is for finite numbers only, so not infinite. UZ means unsigned 0. Only plus 0, not negative 0. Jesus Christ, man. The B in B flow stands for brain from Google Brain. Ah, that's why it's called brain, okay. These are only supported on the GPU. Interesting. Wonder why. I guess it's like a just GPU architecture thing. I don't know, hardware thing. Okay, don't care too much about that. There's a float 4. Oh yeah, I didn't see that. But that's for E2M, right? And also float 8. Yeah. Okay, no, yeah. It makes sense that that's only for GPUs. Numeric literals, interliteral and float literal. Should never instantiate them yourselves, but I guess you can, right? There's integer literals, hexadecimal literals, octal literals, binary literals, and floating point literals. A compile time Mojo treats numeric literals as arbitrary precision values. Yeah, where's the how come 0077 isn't a hexadecimal chart literal? Shout out Verus. At runtime the values are converted to finite precision types. Materialization. Okay, SIMD and D type. To support high performance numeric processing, Mojo uses the SIMD type as the basis for its numeric types. SIMD is a processor technology that allows you to perform an operation, blah blah. So they have two parameters. The D type, which is the data type. Okay. Why don't you just call it data type, dude? The number of elements in the vector, which must be a power of 2. Math operations on SIMD values are applied element-wise on each individual element in the vector. For example, why do I need to pass it as an enum? Why can't I just pass the type directly? So it says the basis for its numeric types, but how? Like, is an int 32 a SIMD type? The SIMD module defines several content values that function as type aliases, shorthand names for different SIMD vector types. So a scalar is a vector with a single element. Yeah, so int 8. I mean, again, like, why? This means that whether you're working with a single float32 or a vector of float32s, the math operations go through the same code path. Maybe that's useful, I don't know. Like, a useful distinction, I don't know. The D type struct describes the different data types that a SIMD vector can hold, and defines a number of utility functions for operating on those data types. Is it, so then it's, okay, so it's not enum. The D type struct defines a set of comp-type members that act as identifiers for different data types. You use these comp-type members when declaring a SIMD vector. No, it is a enum, more or less. You can't create a variable with the type. Okay. D type is floating point. I wonder if this comes up in reflection. Numeric type conversion. Strings. UTF-8. String is mutable. Construction, writable traits, emoji, okay, family, flag, wave, namaste. What? Sorry, it's just so small. Mojo's 4-digit. Sorry, if you rather not embed non-ASCII characters, you can backslash it with a hex escape, or use chur. I like chur. Mojo's 4-digit UHHH escape spells code points up to U plus. What's H? It's a standard. Both forms reject surrogate code points. Surrogates are reserved for UTF-16. String formatting. The format method inserts values into a string using manual or automatic positional indexing. Ah, cool. I still wish I could do dot print, but whatever. But there's also T for template strings. What's the difference there? Mojo's T string template string replaces the functionality of the format method with direct expressions. And better performance. T-strings with like format where they insert. I wish it was capital. That's my main concern right now. Well, no, I mean my main concern is I wish it didn't have the prefix, but T-strings values are lazy. They don't allocate unless you explicitly construct a string. T-strings can add arbitrary expressions within the replacement fields. Syntax highlighting may prove to be an issue. Raw strings are string literals with R as a prefix. And you can do RT for a raw templated string. Okay, string literals, as with numeric types, they are a string literal type. When adjacent, they are concatenated. There are multi-line strings, which are also used for dot comments, for reasons I do not know yet. Bool represents a Boolean value. I do like how types have a capital letter, by the way. Rust decided to just inherit the C++ mistake, or C mistake, I guess, of having lowercase type names. Not Mojo. You can negate a Boolean value using the not operator. Is there and an or then? I hope so. Many types have a Boolean representation. Any type that implements the boolable trait, boolable, you know, it works, as a Boolean representation. As a general principle, collections evaluate as true if they contain any elements, false if they are empty. Strings evaluate as true if they have a non-zero length. I'm not a fan of boolable, to be honest. I mean, actually, I just want to check, like, is empty explicitly? Saying like string, like not string, like it just doesn't read, you know. Tuples. Mojo's tuple is a lightweight, fixed size, heterogeneous collection with value semantics. That's this tuple there, and there's a tuple type. Bit weird, but yeah, I guess it's the job done, I guess. You can also create a tuple without explicit typing, of course. Do I need explicit parentheses? Let's see, you access it like array indexing, which makes sense. I don't know why you can't do this normally with tuples. Like, I don't know why they insist on like .0 and .1. The Mojo standard library also includes a set of basic collection types that can be used to build more complex data structures. List, text set, optional. Yep. The type can be inferred. Oh. Can I say list and then have that be inferred without specifying the content type? Variant. Okay, list supports a subset of the Python list API. Okay. Okay. Yo. List comprehensions. X times int y for x in nums for y in list if x equals 3. I mean, that reads like absolute tragedy, but it's cool. Haskell. You can't print a list or to convert it directly into a string. Yes, you can. I'm pretty sure I did earlier. Weird. Shown above, you can print the individual elements in the list as long as they're a writable type. Iterating a list returns an immutable reference to each item. Immutable. Okay, so that's a reference. If you'd like to mutate the elements on the list, use ref. Oh. It just said immutable reference, but here it says instead of making a copy. Oh, you mean instead of making a copy? That's just confusing. Like, this says ref, but this is a reference. It's just immutable. Here, it's also a reference, but it's mutable. So why is ref used and not mutable? That's a smell. You can see that the original loop entries were modified. The dict type, okay, use a set pair notation instead. There's also a set. What's the difference between an empty set and an empty dictionary in this language? Doesn't say. Optional. May or may not be present. None is also used. See, that's just okay. Yeah, 5 or none. Opt.value. If opt. Okay. I haven't seen pattern matching yet. This language better have pattern matching, or it's gonna be a tough journey. Then again, C++ doesn't have it yet either, so. To Rust, man. Alternatively, you can use the or else method, which returns a stored value. Okay. I mean, it's just so far from what I've seen from the error handling in this language, it's not great. It has exceptions, and it has try catch style exceptions. So like the syntax isn't even nice, and it has errors as values, but they're not like there's no special syntax support for them. So it's kind of not good anyway. Operators are symbols and keywords that act on values. There's no op plus, inverts the bits. Remainder is modulo. Double slash is for flooring division. Sure. Exponentiation. Matrix multiplication. What? The at operator performs matrix multiplication. Mojo doesn't include a built-in matrix type, but any type that implements matmul can use it. Sure. Comparisons, I mean, bit of a tragic use of the at operator. Like, why don't you just do times? And like overload it or something. Mojo provides 6 comparison operators, equals, not equals, less than. Floating point comparison, use it close, change comparisons. Oh yeah, that's a cool Python feature. The expression ABC is equal to this. Comparison membership and identity operators share the same precedence. 5 does not equal A, and A is less than B in C is D. What is? Did I miss that? Comes later. I think it's to do with like types or something. B in C. Bitwise operations. I'm glad to see and though. That's nice. Yep. Bitwise, kill me. Among the bitwise operators, precedence runs. I mean, I get it. It's low level, but it's a waste of good symbols, you know. Boolean logic and or not. Short circuit. Truthiness. Types that conform to boolable have a truth value, so they can be used directly in Boolean expressions and if conditions. The rules are predictable: 0 empty strings, empty collections, and none are false. Don't like it. Membership and identity. The in operate. I mean, again, same issue with C++. Rust might not. The in operator checks whether a collection contains a value. Red in colors, yellow not in colors. It also works with strings to check for substrings. Is whether two values refer to the same object, not just whether they're equal. Looks like pattern matching to me. So, what does that mean? Refers to the same object. What does that mean? I need more examples. String support concatenation with plus and repetition of times. Yeah, times being for repetition. I mean, sure. What else? Honestly, when building a string for multiple values, the multi-argument string constructor is more efficient than chaining. Why can't that be optimized? Strings compare lexicographically, uppercase letters sort before lowercase. Because like this is just a space, right? Unless it doesn't, that's just a print thing. They do compare. Mojo uses if else for conditional expressions instead of ternary, thank God. You can use this form anywhere, an expression is valid, including functional arguments. Like exponentiation, change ternary expressions or right associative. Yeah. Assignment operators. The walrus operator, officially an assignment expression, assigns a value inside an expression. That's just not necessary. That's just not necessary. I don't like it either, because like, again, it implies, like, the symbol literally means type inference. Like, it's colon equals. It's meant to mean type inference. I don't like it being overloaded like this for no reason. I mean, not even overloaded, just given this use for no reason. Precedence. When an expression mixes operators, precedence determines what runs first. Rust, by the way, also doesn't treat this operator correctly. In fact, does it even have it? I don't think it does, which is annoying. They are calls and actually express. When in doubt, use parentheses. They cost nothing at runtime and make your intent clear, both where you write the code and when it is later read and maintained. Yeah, I'm a fan of parentheses for disambiguating these kind of things. Control flow. The if statement. Mojo supports the if statement for conditional code execution. With it, you can conditionally execute an indented code block, or if a given building expression evaluates true. So, yeah. It is warm. There's a lift as well. Control flow. Is there no pattern matching? It doesn't even support a C-switch statement. Let me ask in the Mojo Discord server. Just reading the Mojo language tour now. I was wondering why no pattern matching yet. These are modular employees. I know this guy. I recognize him. He was I think he's the one who owns the actual Mojo repositories on GitHub, if I'm not mistaken. Whoa. I mean, pattern matching is useful, you know. I mean, it beats chaining if statements, that's for sure. I think the best language for pattern matching right now is unironically C#. Like, it's so random, but like the ergonomics are really good. Rust matching is honestly quite like it's annoyingly underdeveloped. They could have done a lot more with it. Mojo follows structure evaluation for semantics. Okay. Conditional expressions. I think we just saw that already. The while statement. Continue, break. And can someone explain to me? Oh, the else clause does not execute if a breakaway return statement exits the while loop. Okay. I mean, return what? But yeah, because I was wondering, like, why would you need while else? Because like this will happen anyway afterwards. But okay, if it breaks, basically. Fair enough. Very niche though, right? But no, maybe not as niche as I think. For statement. So for loop. Yeah, for statement, whatever. also actually over a set. I assume sets are order independent though, or at least like conceptually they are. You can iterate over a dictionary for a state in capitals. Capitals. This is okay. So this gives you the keys. Items gives you value and key. References, ranges. What does range do, by the way? Yeah. For loop. Control statements. Continue, break, else, yeah. Else. The Mojo for loop. It'd be nice to have like a loop statement as well. Like I know while true exists, but like while true doesn't read cement, like it doesn't make sense. While true, the Mojo for loop supports iterating over while collection types. Okay. Don't care too much about that. Errors and context managers. Mojo represents errors as values, specifically as alternate return values from functions. Unlike stack unwinding exceptions in languages like C++ or Java, Mojo errors don't require expensive code stack unwinding, so the runtime overhead is as low as returning and checking an extra rule. I understand that, but it's just the syntax is just so ugly. This design also enables error handling in contexts where traditional exceptions aren't available, like GPU kernels. Like, please. Just give me some other way to do, like, that isn't try and catch. Because, like, try and catch, like, it forces you to, like, indent, bro. It's so messy. And, like, and like, you have, like, these chains as well of things. Like, it just completely just destroys control flow. At least, like the way you read it, control flow. Like, look at this, dude. Like, look at the nesting on this. Good response. We haven't gotten to it. 1.0 is your point to stop making everything every 4 days, not the language is done. Everything in due time. Figuring calling semantic and foundational traits. See, that's a bit concerning to me because I feel like pattern matching is a foundational thing. I mean, it's a trait to be fair. But, like I feel like it should be a core language semantic thing. Pattern matching. Like, you can't just have match statements, but you lose a lot of ergonomics by not having it built more into the language. But I won't mention it here. Even without stack unwinding, try catch style error handling is just so ugly. Look at the nested indentation. Like, because we got, like, it goes try, then a for loop, then try again, and then an if statement. Like, dude, like, it tries twice. And like what if you're gonna try on like one operation, you know? Like, it's just gonna be so sad. So sad. I don't find it's easy to read over. Easy to follow. Control flow this way. I see, thanks. I do wonder then, does that mean that matching will be limited to pattern matching like within a statement? Did it mention it somewhere? In control flow? Did I miss that? Yeah, here. I'm worried though. Does that mean Mojo pattern matching will be fairly limited? i.e. a match statement. Like just pattern matching should be like just way more of a like a first class feature. Like having like with the is keyword, for instance. It'd be really cool if the is keyword could do pattern matching. Are there plans for pattern matching at the moment? I'm curious if it'll be made, if pattern matching will be integrated into the language beyond just match statements, like having is perform pattern matching and or stuff like if like Rust if let, although a pattern matching operator like is would make this unnecessary. Right now you can do optional value is none, but that's the only example I've seen so far. Plus a language, plus C#, for example, has really nice pattern matching ergonomics. The kind you would expect in a language that supports x less than y less than z, as Python does. C# pattern matching. Just so I don't, give an incorrect example here. Like, you can do like more than directly, yeah. But hey, I will mention it. Okay. Raise an error, yeah, raise an error. Oh, okay, so you don't have to say error. Okay, sure. Handle an error, try, accept, as finally. I feel like I already saw this, right? You can re-raise it by just propagating it, right? Typed errors, custom error type. It's useful. representing multiple error conditions. The variant type. I haven't seen enums yet, by the way. Equatable. I do like how the trait names are very much like able, like copyable, writable, equatable. For Rust, it's just like add, equal, I think. But no, like EQ, like stuff like that. Like yeah, like it's more concise, but it doesn't like make sense to read it. You can then match on specific variants in the handler. Okay, what's the variant type? Oh, it's like an enum, isn't it? Sorry. Where's the enum? Variant int. Not found. File error variant equals 1. Where's that happening? A single struct with comp time variant aliases. So is this just built in? Very strange. And do I need to map to do if on this, or can I just say if equals not found? Variant type. Why is it going the C++ approach? This seems dangerous, you know? Is why is it be like ISA, dude? E? I'm guessing E is just the name here, okay. Is a not found error? Yeah, this is shaky. Like as far as like it's just like the language's evolution, this is shaky. I mean, I'll still probably use it anyway because, again, like neither C++ or Rust currently have this supported anyway. So, but you know, if another language came around, I would use it. So things Rust does will be considered. Of course, it's good to hear, but the lack of patch. Well, I mean, I say that, but I don't agree with Rust's team anyway. The never type is a type with no constructors. It can't be instantiated. Jeez, why does it always raise? Panic. Pretty niche. Functions that never raise just don't. Hey, what? Okay. Parametric raises. Say what? Ah, that's a function. What's thin? Action is a non-capturing function value. Okay. The array type parameter is inferred from the functions you pass in. Types errors in error interaction. Wrap error at API boundaries. catch it and convert it. Avoid bare raises with typed errors. Type erasure. Don't mix them in a single try block. I mean, dude, just don't use a try block. I feel like using exceptions was is also kind of like an excuse to not have pattern matching, because otherwise they would definitely need to have it. Enable stack trace generation for errors. But like the lack of like proper ADTs is problematic. That's where Rust very much wins. Not because Rust even like does them well. Like it kind of like it almost does the bare minimum, but it just does it, and other languages just don't for some reason. So capture a stack trace programmatically. Hold on. Python pattern matching. This is a proposal, 2020. Was it implemented though? Coming in Python 3.10. Well, if it was out already, I assume there'd be like a thing on it that wasn't about a proposal. Yeah, so Python does have some form of pattern matching. Whatever. Capture a stack trace. Context manager. Does not agree with me. Okay. Can I move on from this? Right, so we got structs. Mojo structs. Why are they called Mojo structs? Like, they aren't Mojo functions, but they're Mojo structs. Which sounds like they're particularly important. A struct is a Mojo's primary way to define your own type. It's kind of the only way, really. A new exception uses structs. There's no classes yet, anyway. At a high level, Mojo structs lets you bundle. Why even have classes in the language? Like, a struct is just a closed class, basically. Each Mojo struct is a data structure that you can see fields and methods. Yeah, dunder methods. It's a naming choice. Struct definition, out parameters, constructing data type, mutating a struct. Yeah, mutable self. Make it copyable, movable, copyable, implicitly copyable fields. Any getters and setters, like for the fields. So there's not really shadowing it because you can only access it by yourself anyway. Field conventions. Prefer snake case. Man, I want to use camel case. Use descriptive names that indicate purpose and other type. Error message, not message string. For members meant for British to use, okay. Private field for underscores. Yeah, I don't like that. For Boolean fields, use is or has. Or should. Avoid single letter names. Yeah. Methods. Setting methods. Uses this for some reason. Structs compare to classes. They don't exist, it doesn't matter. Special methods. Okay. Operator support. What's I add? Okay, union operators. Builds a complex type. Hold on, subscript. Okay, whatever. Complex type. Boolable, equatable, trivial, register, passable. Writable. So the real and the imaginary. Convenience initializer. Make a type printable. I mean, this is like Garner's straw strip stream right here. Complex. Okay, never mind. No, never mind. If it lets you write I, then that'd be his dream come true. Support binary arithmetic. Mixed type arithmetic. Support type equality checks. Okay. Self-referential structs. Yeah, you need pointers, don't you? Oops. I can finally see what pointers look like. That's funny. There's and used to concatenate traits. Hello, Scowler? I think. Don't like it. Didn't like it in Scala either. Unsafe pointer. A pointer is called unsafe pointer, and you pass a mutable untracked origin. Okay. Building nodes. Linking nodes. These structures, by the way. Yeah, Dell. Okay, so those do exist. Modules and packages. Yeah, modules, just a file, right? Yeah, I was thinking of just having like a module keyword. Rather than it being file level, you just type module and that starts a new file, just so that you can have multiple in one file. Because why not? Then you don't have to worry about having things in different files if you don't want them to be. Module package is just a collection of Mojo modules and a directory that includes an init to Mojo file, organizing Mojo. Mojo C. I think I've seen this in Python before. The init file. Yeah. Okay. Right, now we're getting to the big stuff. So into the value of ownership. A program is nothing without data, and all modern programming languages store data in one of two places, the call stack and the heap, and CPU registers. Not sometimes, very often. Power up to each language reads and writes data bits differently, sometimes very differently. So in the following sections we'll explain how Mojo manages memory in your programs, and how this affects the way you write Mojo code. So text, data, stack, heap. Okay. Right, so garbage collector, yeah. Performance costs. It also can get in your way. Ownership. Right, let's go. Mojo doesn't enforce like semantics, reference semantics. It supports them both and allows. Oh, so it supports both, okay. And allows each type to define how it is created, copied, and moved. So if you're building your own type, you can implement it to support value semantics. Oh, right. That's like how in C# for Java, well, I think C#, structs have value semantics, but classes have reference semantics. Something I never understood why you would do that. Maybe it works particularly well for garbage collection, but for me, I'd rather just have one type and they all move by default. I guess, but like I guess garbage collection would just not move anything. Garbage collection is so whack, dude. Like it's painfully, like it's when you write garbage collected code, it's not just that you don't have to worry about cleaning up your own memory. It's also like the way you write your code is just worse, because like you heap allocate everything. You can't, like, you don't create copies, or like there's no like a move semantics. You just create things. So like it just feels so, it feels wrong, because it is wrong. It's slow. If you're willing to untype, implement to value semantics. Like even if you have really efficient garbage collection strategies, just the fact that everything is heap allocated, and like there's some like optimization tricks, but they'll never be as fast as just writing code the way code was intended. That controls the reference semantic. Okay. Pass by value. Right, ownership. A challenge you may face when using some programming languages is that you must manually allocate and deallocate memory. Mojo avoids these by ensuring that there's only one variable that owns each value at a time, while still allowing you to share references with other functions. Because sharing is caring. Yeah. I mean, this reference counting is one way, but that adds runtime overhead and can also get in your way. The fundamental rules that make Mojo's ownership model work are the following. Every value has only one owner at a time. When the lifetime of the owner ends, Mojo destroys the value. Okay. A variable owns its value, a struct owns its fields. Reference. In Mojo, you want to provide full value semantics by default, which provides consistent and predictable behavior. I don't understand the default value semantics. I prefer. I mean, just like the magic 3 words are moved by default. Like it's just better than copy by default. Just makes it easier, you know, because like if I use it, it moves. If I say it copies, it stays alive. Pretty simple. But as a systems programming language, otherwise I get like a bunch of copies that I'm not even aware of really, because I forget that something is movable. Like literally, like all this that standard move does in C++ is cast something to an R value, and it's like, well, like seriously, like that's what we need to get move semantics. Like just have it by default, and then have copy be an explicit copy. You know, as a systems programming language, I mean. So default is an immutable reference for a function. I mean, these are for functions, but anyway. The function receives a immutable reference. Var takes ownership. Yeah, so for var, it can either be a copy or a move, which is fine. Immutable reference. Dude, var and mutable in the same thing? Like I appreciate how it's not easy to separate these like things, but like just give me a language that just like tries a bit harder, you know. I mean, Rust, it's got let and let mute. I don't know why other languages aren't copying it. Like some languages do, a lot of them don't. I don't understand it. Like it makes sense have mute be a modifier, not a different thing. Or as this language does, it just doesn't even have mute for normal variables. It only has it for like references. And it's like, well, okay, like why? And like even Rust, like it has const, but it doesn't have const mute because it doesn't have comp time. It just uses macros. It's annoying. Ref arguments are an advanced topic, are they? dinit. Dinit is like drop, right? I don't even know. Out. Okay. Yeah, I mean, I'm gonna skip this. I think I got that. What are origins though? The Mojo compiler uses a special value called an origin to track the lifetime of variables and the validity of references. Specifically, an origin answers two checkers. What variable owns this value? Can the value be mutated using this reference? A borrow checker. Is it? I mean, there's no borrowing. For example, consider the following code. The line name equals Joan declares a variable with identifier name and logical storage space for a string value. When you pass the name into the print string function, the function gets a mutual reference to the value. Yeah. I just don't like it. Like, it's just so obvious that it's a reference, you know. Like there's no ref keyword, there's no mutable keyword, but it's a reference. It's like, well, what? It's just so confusing, isn't it? Most of the time, my guess is that it was done this way so that it would look like normal Python code, but is that even true? Is this because of Python? Like, does Python have immutable references by default for its parameters? Because like it's a different model. I mean, Python uses an interpreter. Just like it's not even the same like ballpark. Like I do feel like Mojo should have focused on just being a Python-esque language, like syntax-wise, and being approachable, but not worrying about being a superset, because it just gives you so many issues that don't need to exist, right? Like when you make your language a superset of an older language that has flaws, you are literally dooming it. Like C++ got away with it, and fair enough, but you know, a lot of people don't like C++. Is all I can say, and the reason that it has lived for so long is because it's taken decades upon decades for competitors to actually compete. Like Java, not really a competitor because it's not in the same space. You know, neither is C#. Swift doesn't count either because it uses reference counting. Rust is like the first proper language to contend with C++, and look at it. You know, it's now so many people's favorite language. People love it because of just how because how it breaks that status quo that C++ has kept. I mean, I say it breaks the status quo, not really, but like it's the first language to successfully actually like challenge C++ and like offer itself as like an actual alternative to the language for that space. It's crazy. It's actually insane that it's taken this long. So while I'm liking Mojo, obviously it has flaws, but so do C++ and Rust. So like I see Mojo as like the next step for me to just use a language that is slightly, well, I say slightly, which is considerably less annoying to use. Still annoying, but less annoying. But I would still like a language to just not make stupid decisions. Which sounds easy, or sounds, I don't even know, like, I just don't understand it. Like, why? Origin checking and lifetime checking is done at compile time. Okay, so it is like borrow checking, but just no borrows. Origins don't track the actual storage. By the way, Mojo origin. Yeah, good luck. Good luck looking that one up. But if I say Rust borrow checking, right. Yeah, they're created by the compiler. It supplies a struct and a set of type aliases that you can use to specify origin types. As the name suggests, the im origin and mute origin represent immutable and mutable origins. Or you can use the origin struct to specify an origin with parametric mutability. Origin mutable is mutable. I don't know what this means though. Like, I don't really know how to use this. So I'm kind of just going to ignore it, to be honest. There's ref, arguments. What is that? Ref self. Origin specifiers. Why is self a specifier? The second form includes an origin clause, consisting of one or more origin specifiers inside square brackets. Okay. And the return values, you must provide an origin specifier. Kind of an example. A ref to self.name 0. Well, yeah, I'll come to that when I come to that. Value lifecycle, creation, destruction, deep dive, okay, whatever. Metaprogramming, right? This will be truly interesting. Got ping here. Is just an operator. Any structure is able to define it. The reason we use is with variant is a little more complicated. Algebraic data types and pattern matching are on the roadmap. Is there an in-depth one? These have been covered, right? Non-goals, syntax trigger, anti-Python style code, library parity. Okay. I mean, delaying async and like pattern matching, like ADTs, it's not. I feel like it's not a good idea to like add them separately. Like I feel like it's repeating the same mistakes that other languages do, which is address them later. So then what you'll get is like async Mojo, which people treat as like a different language, because it's just so disconnected from the original language. Yeah, this makes me skeptical, because I worry about the language's future. But whatever. Doesn't even matter that much anyway. I mean, like, to me, you know, like, I don't really care that much if Mojo succeeds or fails. It's more just, you know, I'd have an easier time if I get to use a language that already fixes more issues than it doesn't. Okay. There's a detailed roadmap page. Does Python have exceptions? Python exceptions. Yeah, it does. If only aided or added it does it nice. But my exception, hello exception. I want exceptions at the start. But okay. Nah. I've got to use it to believe it, because it still doesn't look good. Just looks like try and catch, but in different clothes. Not even like different, like not even significantly different. Main languages have facilities for metaprogramming, writing code that generates or modifies code. Python has dynamic metaprogramming, but they're dynamic. Yep. C++ templates, hard to use. Yep. Mojo Cartel metaprogramming systems use the same language as runtime programmers. So you don't have to learn a new language. It's comp time, shout out zig, parameters, traits. Go pattern evaluation. Right, so comp time size, got like 4. I mean, it's not that crazy, is it? Control flow, conditionals. Pretty simple. Parameterization, already saw that. Oh, Jesus, a lot. Just gonna skip that, I think it's a bit redundant. We've got traits. Polymorphism. As a trait keyword, just give it functions. I mean, yeah, it's pretty straightforward. Things to know. You can't add them to existing types. I do like that. I think that if you want to extend a type, you should create a new type. But I don't know how nice that is to do. Conformity is explicit. A struct that happens to implement fetch reading doesn't conform to the function sensing. Unless it declares a trait. Yeah. So not duck typing. Traits are all or nothing. Yeah. You can't partially have a trait. Parameterized declarations. Why are there so many things here? Constraints. I mean, it's nothing too crazy from what I've seen. This is different. Constraints. Can't believe that Python got reflection before C++ did, or before Clang did. So is this a runtime assert? Proposition. Or are they compile time? Also, how would it know? So I need to know, are constraints called a compile time? Constraints are, as far as I'm concerned, are only useful if they are called at compile time. Runtime constraints they don't do anything. They just add overhead to like performance overhead and give you errors. Like I don't want to do that. Like that shouldn't be a core language feature. It should just be used for like statics. I mean, not static, through asserts statements, or like if this and throw error or something. At the end of a function method or in the parameters of struct declaration. Yeah, where conforms to. Okay. Symbolic propositions. Knowledge. So knowledge base. Sure. That's one way to think about it. I wonder how slow that makes compilation. Hopefully not too slow, because I do root for this feature. The message is optional. In general, it's safe to assume the constraint system doesn't evaluate propositions directly, and that all knowledge needs to be provided explicitly. However, the constraint system does apply a very limited amount of smartness for very common cases. The goal is to provide a consistent principal experience. Okay. So only use constraints if your function doesn't handle the entire domain of its input types, if it isn't central to the concept of your library, and is understandable by the caller and provable. Sorry, is it runtime, yes or no? The caller must explicitly provide evidence that the precondition is always satisfied. Okay. Okay, this is good. This is very similar to what I was kind of trying to figure out for my language. Well, I mean, so I said for my language, for a language in general, just to find a good way to do it. This is cool. I want to check those out more. Materialization. What? What? Making a compile time value available at runtime. Yeah. It's an interesting problem, and why I prefer maybe to not even like disambiguate compile time from runtime, and just have to have the compiler decide which ones can be which. Reflection helps you write code that inspects its own structure at compile time. Why reflection? Why reflection? Inspect the type. Yep, name, field count, field names, field types. Awesome. Yeah, we'll definitely use this at some point. I mean, honestly, like the potential for this as well. Like, I mean, just as well, the potential for this is insane. Like the fact, like, my main use case right now, for programming is modding, and if users can use a language like this, and even like interop with Python, or like I don't know, like hook my things to their Python projects, that'd be really good for accessibility. So you know, it's nice that the language is also good. I still think that, again, it doesn't have to be a superset of Python. Like, it can look Pythonic, or like, you know, I say Pythonic, I really just mean it can look easy, like it can look approachable, but then like just, you know, happen to have also really good Python interop. Like it could do that as well, but yeah, it can't be ignored that supporting that being a superset does have its advantages. And given Python will probably be around for a long time. A pointer is an indirect reference to one or more values stored in memory. So this owned pointer, right? So pointers are quite verbose, I guess. Like you say owned pointer, I assume shared pointer. No, okay, never mind. Just pointer, owned pointer, arc pointer, unsafe pointer. That's fine though. Ooh. And you dereference using the bracket. Okay, yeah, I've seen that before in other languages. Maybe Python even? You know what, yeah. It's, realistically, what else are you going to use, right? And if you don't support the star syntax. Safe pointers, double pointers, end pointers, yeah. I'm not going to worry too much about pointers. You realistically aren't going to use them too much anyway. It's more for like references, like shared reference is more what it is, and those are easy enough to use. It's more the roll pointers that are more of a concern, but I can cross that bridge when I come to it. Using pointers, if I'm lucky, I won't cross it for a while. In Rust, I cross it immediately, and it, well, it's not why I don't like the language, but it did not leave a good impression to begin with. Pointer basics. Yeah, don't really care too much about that, to be honest. Closures. They're a long-standing part of Mojo. Okay. A closure is a function of altogether values from a standing scope. They look like nested functions, but they use a special syntax. Create braces after the argument list from a capture list. Yeah. Interesting. So they can't be anonymous. Unless lambdas can also be closures. Holy moly, this is long. Okay, so a bunch of different capture types. And yeah, that's basically it. And then lambda expressions can we also capture? It's a small anonymous function, like a name function, it accepts arguments, returns a value, and can capture values. Oh, can. But do you, like C++ lambdas do capture as well, and they're anonymous. Lambdas are most useful when an algorithm stays the same, but one small piece of its behavior changes. Lambdas and closures, okay. fine. It uses Python lambda. The thing is though, they might add syntactic sugar down the road. I don't know if that would be useful for this kind of thing, but oh well. The body is, I mean, it's just so verbose, isn't it? The body is always a single expression. When you call the lambda, the expression is validated and its result returned. It's always a single expression. Oh. Oh. That's weird. That's actually, yeah, well, that's really weird. But the same behavior you'd expect from a named function with less ceremony. Inline lambdas. Side effects. Okay, so yeah, so they do have closures as well. Or captures, whatever. Higher order functions. What's a C int, by the way? I thought C int, like, is a C int not just an int? Using a lambda gives you customize maybe the call sign. You choose any effect so long as the shape of the lambda matches. Okay. Bubble sort. Takes a function, so use def tft to boom. Do named arguments play a role in this? I don't know. Thin lambdas carry no state. Right. In place transform. That's just a map. What? That's weird. That's a weird way to have mapped. But, eh? Like, imagine if this whole thing was just times 2. Like Haskell does, you know? Well, could be. Lambdas and closures. Okay. And interop. Right, so you can import existing Python modules and use it in a Mojo program. This is 100% compatible because we use the C Python runtime without modification for full compatibility with the existing Python libraries. You can construct Python objects. Okay, but it doesn't mention that you can't compile. You can extend your Python code with high performance. See, this is cool. Calling Mojo from Python is the main thing. Because like, I'm not going to want to use Python libraries anyway, but I will want to do the opposite. Mojo is a compiled language. We can't directly evaluate Mojo code from Python. Instead, you must declare which Mojo functions and types are available to be called from Python, and you can import them in your Python code. Yeah. So it has to be compiled, but because the syntax is like similar, I think it should be too difficult to do that. By embracing both directions of language interoperability, you can choose how to use Mojo. Okay. Don't know what it doesn't tell you. So calling Python from Mojo. Okay, but you can't compile. You have to mention that. Like, you shouldn't have to rewrite them in Mojo, but you do if you want to compile your application. Mojo build doesn't include the Python packages used by your Mojo project. Instead, Mojo loads the Python interpreter and Python packages at runtime. Yeah. So like, it's loaded at runtime. Okay, no. So I guess you can compile it then, but it will load them at runtime using with the Python interpreter. So you know, just expect it to be slow. Import a local Python module. Okay. And for vice versa, it's in early development. Okay. This is Mojo. ABI is she. Why? Okay. I mean, it looks simple enough on the Python side. Mojo cache. Cool. As long as it's automatic, it's fine. Yeah, that's quite attractive. Lots of scenes drop here. Oh boy. Okay. Tools. Jupyter Notebook. Yeah, I don't care. Targets. These are just examples. Is there like a list of them though? Call it in C++. Interesting. Feature toggles. You can turn off compile time conditionals. I don't know why you do that. Debug assert. Oh, is it for assert? Oh, okay. Debugging. Oh, like a literal debugger. Okay. AI skills packaging. And these are the packages so far. There is a Raylib one and JSON. Extra Mojo. So that's interesting. What's filtering? Kelvin, HTTP. We could also do some HTTP stuff. FMPEG, FFmpeg, image processing, terminal stuff, testing, Mogo. People call me Kojo sometimes, like some people. libc, YAML, CSV, libclang. There's Raylib. Do you want to check out Raylib? Well, I said check out. I want to use it for my Conway scheme of life. Mosaic MSL. NI mtest. Another testing framework. Differentiable. What? New Pi. New Mojo. Project Odyssey. Date time. Okay. Vulkan bindings, by the way. That's cool. What's this about then? Buffered reading, CLI os parser for byte strings, BB hash, bitvec, saturating add and sub. Okay. Test runner. Okay. More testing. Jeez, okay. Here's Mojo Raylib. It was last published 4 months ago, so I don't even know if it's compatible with... I mean, it would be, right? I thought the language has changed so much that, like, the interface has changed, but... Could be wrong, though. 4 months is a long time. In July, I got 3 downloads. What's a arch and normal 64-bit? Only 44 packages in the modular community so far. Let me check. Wait, what is prefix anyway? Let me check the repo. It's here, right? Last commit was 2 months ago. I'm guessing this is the project. I hate how they organize these things, dude. Raw. External call. Okay. Pretty straightforward. Obviously a lot of bindings to generate. Probably use AI for, well, probably can just use AI for a little bit. And save. Init. Types. Callbacks. Okay. There are examples. It's quite handy. Game of life, look at that. Init window. Set target FPS. Yeah, it's pretty straightforward. You just import what? Well, all this stuff, I guess. You could also like make your own like wrapping for it as well, whatever, just to make things more, I don't know, uniform, I guess, like more, just a better interface, honestly. Yeah, it's quite straightforward. So I'll definitely want to get Pixie installed, because like that is what it recommends anyway. Native, so let's see. Figure that bool is not even like a built-in type in C. Yeah. Okay. What a shame, by the way. Damn. Vendor. That's for Lib. Okay. Assets. That's just for the thing, right? Yeah. Cool. Well, I'll use it at some point. Should I do it now actually? Oh, Pixie is prefix. Yeah, like modular. Schrodinger, AWS. Okay. I mean, whatever. If the language uses it, I'll use it. But it's cool that it's not just for Mojo. Then again, I do appreciate a dedicated one. Oh, it's different ones. Conda, Mamba. Are Conda and Mamba both snakes? Anaconda. Yep. Black Mamba. Yep. What's Pixie then? What does that mean? Add it to your workspace. What does that mean? Okay. Just add a pixie.toml. Do I need all those channels? Path to Mojo Raylib. Let's make it up. Mojo build, mainlet Mojo, xlinker, elk on the prefix. I don't know, man. Are these examples like self-contained projects as well? Seems so. There's main. Basic window, keep it simple. Where's the Raylib? Doesn't say. I guess like that's where it puts it. But okay. Might as well try, I guess. So, first of all, let me see if I can install Pixie. Exists, good. Failed, but I guess it succeeded anyway. Yeah. Okay. We'll go to my project then. Game of life. And quit. So what? I just create a pixie.toml. Okay, I'll just copy the stuff and paste it. Name, Mojo, Conway, no, Mojo Game of Life. Version, doesn't matter. Yeah, go off. Well, no, build source / main. I don't understand this at all. It's very, very unclear instructions. Yeah, I need more specific instructions on getting on importing the raylib into my library via Pixie. Should be Linux 64. Okay. I mean, do I not have both? Yeah. Clone it somewhere permanent. Confirm the submodule pooled. Give the absolute path. No. Well, what? What if I want it to be local to my project? Is vendor a thing? So why is there no source? I'm very confused by how people organize their things on Linux. On not Linux, Python. Okay. So the path I'd want would be extern / mojo raylib. That's it. Yeah. So yeah, I mean, the same way I do my C++ projects, but really anything. And then content package ignore. I think I add that to my git ignore as well. This doesn't have it, does it? .pixie? No. So even like the lowk file, would I include that? I don't know. Balat.pixie. Okay, so let's get some module add or init even. No, it is add. Yeah, branch main. Is that not it by default? I guess I just want that branch. Branch main of that repo and add it to extern / mojo raylib. Okay, and then in extern we have that. Extern / mojo raylib, we have that. Looks good. Then I need to get submodule update init recursive, so clone everything else. Might take a second. it does this funny thing where it doesn't show you the progress, but. Okay, done. So let's try again. Pixie, run. Help me, Claude, help me. I just installed it. Zero point 4.0. Something to do with channels? It's what it says on this thing, isn't it? Technical issues here. They're using Conda. What? But what does any of this mean? mean, it seems like it should just work. But it doesn't. Pixie run. Run is the command. Failed to solve requirements environment default for platform x84. Pixie builds Mojo. Cannot be installed. No viable options. Right, I'll follow what Claude says, but like I'm very much blind with it. Same error, more or less. Okay. This is very bizarre. Some languages are pretty straightforward with compiling, others are not. Why can't I just use Mojo? Like, do I even need a build system? Clear state and retry. Okay. To clear state, we'll just remove the. Okay. I don't know if it's like it's outdated or what. I can't fix it. Can I do this without Pixie? Like with just the Mojo compiler? CMake? I need help with this. Let me just ask here. There isn't a help channel. I'm having issues using this package. I've tried using Pixie. With the example toml the repo shows, but I get the following error. When attempting to run. No idea what this means, to be honest. Never used Pixie before this. Can anyone point me in that direction? Or is this a or is this an issue with the package itself? Well, there you go. Mojo. Whoa. So yeah, Brett Mojo. A bit more information on Mojo. Mojo. So I couldn't get the package working, but I'll see if I can figure that out. Once I can, if I can, then I'll get on that. If I can't, then I guess I can't do anything. Really annoying, honestly. Yeah. Oh well. If it doesn't work, then I'll just leave it until it works. Yeah. Not too much more I can do about that. I'm sure development will be fairly quick anyway. I mean, the sooner I can use this language, the happier I'll be. So there you have it. Otherwise, yeah, I mean, I've kind of said it already, you know, like, I'm worried about how this language will evolve, or sorry, how this language will kind of stand the test of time. I think it's already making what appear to be mistakes in its design. In that, like, it's not considering like async, pattern matching, effects even in its core design. It's adding them as features later down the road, which is like, you shouldn't be doing that. Like, the whole advantage of making a new language, is having the foresight to add these features, you know, that the other languages couldn't. So, I mean, it definitely fills a niche of like Python, low level CPU AI programming, and I'm worried that that's the niche it will continue to target only. I just want it to also just be a general purpose programming language, and to do that, it needs to really think about these features and get a better package or like, it's like some better package management scheme, or like something. I mean, like, at least CMake, like, I can use CMake, you know, like in C++, like, yeah, like, it's not great, but like, at least it exists. Like, here, I need to do like this, like, I need to use CMake on the thing, and then do some compassing with GCC, and then use the Mojo compiler with a bunch of like flags that I don't understand, like a lot of them, and it's like at that point, just like, what? Why is it so complicated? Yeah, I don't understand. So hopefully I can figure that out. But yeah, anyway, that's Mojo. There is the Mojo game thing, which I might look into at some point, but I mean, it's called Mojo Quest. It's called 6 Days to Learn Mojo. Um, but I don't know if I'll do it necessarily. Like it teaches you the language, but I can learn the language just by making projects as I am already. So I don't know if I'll go on with that. But tell you what, even if I can't get the Raylib thing to work, I'll probably at least refactor the code I do have that runs in the terminal and get that to work instead. But just like refactor it to see like to kind of push like what is the abstraction potential of this language. Right now I expect it's not very high, but at least to see how it compares to C++ and Rust. Both in like, not just like the capabilities, because I'm aware that it has like traits and stuff, but and like metaprogramming, but also in the how it reads and how annoying or not annoying it is to write. So yeah, to be continued, I guess. Otherwise, I want to start reading some of these other books that I have, like Introduction to the Theory of Computation, and even then, I also want to finish Swift. Like I did the whole Swift introduction, but I haven't gone into like deep into the language yet, so I might look into Swift and finish that up. But I'm just wary that I will do Swift soon in university, so I mean even then though, like I feel like the lessons for Swift are gonna be so slow that I might as well just learn it now and like just get through it. Yeah. I also like at some point I do want to start implementing True like my language, but I'm like it's just still like so up in the air, like from syntax to everything, that there's no point in making a compiler at this point, other than just like learning purposes. But like yeah, nah, I got to think more on that, and to think more I need to read more. So that's probably my priority right now, just reading a bunch of things on language theory and stuff like that, and yeah, see where it takes me. All right.